We are going to explore our solar system and appreciate what causes daytime and nighttime as well as tides and seasons. Subscribe and like if you find the video helpful. Have you ever wondered about the grand cosmic dance unfolding above us? Well, even the first astronomers marveled at these celestial bodies, which kindled in them a burning desire to peek beyond the veil, and boy did they unravel cosmic mysteries bit by bit. They pieced together this ballad where the sun, the moon, the planets, and the countless other celestial bodies that make up our solar system, each has a stanza in this intricate ballad of the cosmos. Our journey begins with the sun, the powerhouse of the solar system. A blazing sphere of hot plasma, it's so large that over 1 million Earths could fit inside it. It's this colossal size and the intense heat generated by nuclear fusion at its core that makes the sun our system's central gravitational anchor. Next to it is our solar system. The sun is the third planet in the solar system. Mercury is the closest planet to the sun, a small rocky world scorched by solar radiation. Venus, our second stop, is similar in size to Earth, but with a runaway greenhouse effect that makes it the hottest planet in the solar system. Our home planet Earth is the third rock from the sun, a blue oasis teeming with life. It's the gravitational pull between Earth and the moon, our planet's only natural satellite, that gives our ocean tides. A tide is the daily rise and fall of oceans that cover about 70% of the Earth's surface. Tides are the result of gravitational forces of the moon and to a lesser extent the sun. The gravity of the sun also pulls Earth's water towards it and causes its own tides, but because the sun is so far away, its gravitational pull is smaller than that of the moon. However, when the sun and moon are in line during the new moon and the full moon, their high tides add up and create a spring tide. During a spring tide, high tides are really high, which means that low tides are really low, creating a large tidal range, and it's the tilt of the Earth's axis, combined with its orbit around the sun, that gives our seasons. A common misconception is that the sun is closer to Earth in the summer and farther away from it during the winter. Instead, the seasons are caused by the 23.5 degrees tilt of Earth's axis of rotation relative to its plane of orbit around the sun. At summer solstice June 21st or 22, Earth's axis points toward the sun, and so the sun is directly overhead at its furthest north point of the year, the Tropic of Cancer. The Earth's tilt on its axis leads to one hemisphere facing the sun more than the other hemisphere and gives rise to seasons. The red planet Mars is next, a rocky world with the tallest volcano and deepest canyon in the solar system. Between Mars and Jupiter lies the asteroid belt, a ring of millions of space rocks, remnants of the early solar system. Jupiter, the largest planet, is a gas giant with over 70 moons. Saturn, famous for its stunning rings, follows. These rings are composed of countless particles of ice, dust and rock. Uranus, the ice giant with a unique sideways rotation, and Neptune, the furthest planet from the sun, known for its intense winds. Complete our tour of the planets beyond Neptune, we find the Kuiper Belt, a massive ring of icy objects including Pluto, once considered the 9th planet. So from the fiery heart of the sun to the icy reaches of the Kuiper Belt, our solar system is a place of incredible diversity and beauty. It's a cosmic ballet with the most impressive and most beautiful objects of the universe, and with each planet and celestial body dancing to the music of gravity and time. To recap, we've journeyed from the sun through the inner rocky planets of Mercury, Venus, Earth, and Mars, past the asteroid belt to the gas giants of Jupiter and Saturn, and the ice giants of Uranus and Neptune, and finally to the icy objects of the Kuiper Belt. We've seen how the sun, moon, and Earth interact to give us time, seasons, eclipses, and tides. How? During the summer, areas north of the equator experience longer days and shorter nights. And how, concurrently, in the southern hemisphere, the sun is as far away as it could be, leading to winter conditions, longer nights, and shorter days. The opposite occurs on winter solstice, which begins on December 21st. We've explored the main features of each planet and discovered the vast variety of objects that make up our solar system. Remember, the next time you gaze up at the night sky, you're not just looking at stars, but a grand cosmic dance. Be on the lookout for more videos on this channel.